I'm going to talk about the 60 text justification. The question is given an array of strings, words, and a wide max wise formatted. How do you say it? Format the text such that each line has exactly max wide character and is fully left and right justified. You should pack your words in a greedy approach, that is, pack as many words as you can in each line. Pad extra space is empty when necessary so that each line has exactly max wide characters. Extra space between the words should be distributed as evenly as possible. If the numbers of the space on a line does not divide evenly between words, the empty slot on the left will be assigned more space than the slot on the right. So for the last line of the test, it should be left justified and no extra space is inserted between words. So the note is a word is defined as character sequence consistent of non-space character only. Each word's length is guaranteed to be greater than 0, not exceed max width. The input array words contain at least one word. Okay, so let's write this code first to. That's kind of like a greedy, right? So you have to check current here. Now space for here. So how many lines? It's the last words, okay? So this here. So it's kind of greedy. You check stuff from the first word to add here, and you can check the current line whether it has any empty or something. Let me change the. Where's my status? I can change. Not this one. I want to change my status to like focus on which one? This one. Oh, focus. Okay, so let's see the list, right? Without new array list. And then after this finish, return the result. So we can do is currently now we can have the words. Okay, I want to have the while loop while smaller than the n. Okay, so int I equals the here. Also int j is stuff from the I. We can take first this one example. Like I means current start here, as j is kind of like means start here. Where is stop? So it's more like 2 pointer to solve this problem. So initialize here. Now we have the line length is equal to the start from 0. Now we need to pick up how many current line length, how many words we can pick up. So the first thing is while j is smaller than n at the same times line length should smaller plus current pick up the word, right? Current now, for example, we pick up this. Okay, pick up this. So words j length, and also we have to pick up the empty, because when we pick up this one, we need to have some empty here. And go to the next. J minus I. This should smaller and equal than max YTH here. And then every time we can update the length. Because we pick up this word, so current line, the length should be updated. Line length plus the words J length. Also, the J should plus move to the next one. So next one, so we can pick up current maximum is 6, right? 6, so we can pick up this one. It's okay, and just one empty here. And then for here, it's also can, okay. How many we have? 8 now. But the example here, we have 11 now. We have 11 lengths now. But J not work, so which means we current lines J have to stop here. J have to we check this one, right? J finish plus to check current here. It will not update here. So J is stop at here. 0, 1, 2, 3 here. J is stop here. We can have the word count is equal to the J minus I. We have pick up 3 words. So 3 minus 0 equal to 3. And also we can know how many space we added. Spaces is equal to the max minus line length. Current we have the 6 minus 11. 6 minus 11 is equal to 5. So we have, this is 11, so we can space 11, need to analyze. Okay, for here we have the different situations here. If the J is equal to the n minus 1, okay, is equal to n, the last one. This one is means the last line or last word. So if we just have the last word, is we're going to here. Right, last line when it's finished, J is equal to it will jump out. And then when is the last word? So I is equal to the words I is equal to the I is equal to 0, equal to the n minus 1. see. So suppose we are current here is just a normal one, right? So we just finish this one. So last line have some special here. So for here we can do something j plus plus j at 3. And now we can have the slot is equal to the space. Slot is word count minus 1. Count here we have 1 slot, 2 slot. So 3 minus 1 is equal to 2. And also for the space, and for the, this is called what? Each word, right? Each word, how many? And then spaces divided by the slot. And for the extra is equal to the spaces modify the slots. Because we have some condition here, we can see, you can see if the number of the space on the line does not divide evenly between the words, the empty slots on the left should be assigned more space than the right side. The left side should be more than the, you can see this is quite different. Now we becoming to put the words in the stream builder. So I need to create a stream builder first. Okay, we have the stream builder. For int k is equal to I, k smaller than the j, k plus plus. For now, space count equal to the each plus the plus this extra. K minus the I smaller than the extra. We will have the one. This purpose is kind of like x. For example, for here we have the each space is what? 11 divided by, what is space? Space we need, this is 2, and the space here we have 5. So 5 modified 2 is 2, and 5 mod 2 is equal to 1. So for here we have the space. Based on these conditions, so k start from the I is 0 minus 0. So we pick up the left first slot, right? It's smaller than the 1. So we can put in the first here. So we can do this, wire the space count smaller or larger than 0, so we can for here we should update the and words k, and then words must be append empty, and append, okay, so this one is added the word, added the, so for here we have the stream builder, right? So add the this first. First is this. Now we add the space is each space 2 plus current is 1, so equal to the 3. So we have the empty 1, 2, 3 here. And space count minus minus. Okay, this one is finished. Now we can, this while loop is finished, we need to add the, and it will keep going, right? It's a is, then go to the next. Because J is here, so go to this one is here, and is, for here is 2 plus the 1 minus I is, K is what? K current, K is 1. Okay, 1 minus I is stuff from the 0. So it should be the 2. So which means current extra 1, it's where put in this here now. So we just 2 here. Oops. And then keep going to the next one. Next one is 2. So this is the last one in here. So how many we have now? We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? This is 9. This is 10. For here is 11, 12, 30. See, this is 1, 2, 3, and 4, 5, 6, 7, 8, 9. This is, how many we have? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Uh-huh. Oh, okay, I forgot this. It's 3. No, it's 1. What count? Okay, so current here is 2. 2. Sorry, 5. Sorry, I needed to print out something. Extra. Wire space. Space cut. Or this is about this one? Is 0. How many is 5? I got confused now. Wait a second, huh? Five modified 2 is equal to it's equal to 2, right? So it makes sense. Ah, okay. Yeah, it's 1, right? Okay, it's 1. And 5. It should be so max wise we don't have the example for this one. So which means the maximum divided by the this one got something problem here. Not how many about this? 1, 2, 3, 4, 5. This is minus 8. It's equal to 8. Yeah, this is right. 8. Right, space 8 divided by 2 is equal to 4. This coming is 0. This one should be 4. 4. 4. Yeah, this works now. There's something. Okay, this is here. Okay, so count is makes sense now. And every time we finish the line, we added the array list. So sub without add to string, and also update the I is equal to j now. So which means I is moving to here now. And now we go to the next line and keep doing the same thing. J is example here. So we have the example. And J is equal to 3, smaller than the N is 1, 2, 3, 4, 5, 6, 7. N is 7. Smaller than 7. Now we current length, right? Current example here. Example is how many words it have? 1, 2, 3, 4, 5, 6. This is the example. We have 7 here. So 7 plus this one, J is, for the first one is 0 plus the 7 plus the 3 minus 3. So it's 7 plus 0 is equal to 7, smaller than the 16. Now we keep 2, for here is 7, and for here plus value is 4 now. Now we keep going for the next one, is off. Off is 7, 8. Off is 7, 8, yeah. J is equal to 4 at the same time 0. Length is 7 plus the 2 plus the current J4 minus 3 is equal to 9 plus 1 is equal to 10, smaller than 6. That's smaller than 6. So for here we have 10, and J is also moved to the next one is 5. So J is moving to the 5 here. Here is 4, 5. J is moving for the test. So test is the 9, 10, 11, 12, right? Okay, so it's okay. So we keep moving here. J is equal to 5 at the same time. 7 plus the, not 7, it's 10 plus the previous 10. Previous is what? Previous length is that 10? Of is 8, not the 10. So here's 8. First is 6. One, 2, 3, 4, 5, 6, 7. 7. Okay, 7. The previous has 7, and current now has 2, so it should be 8. 7 plus 9, it should be 9. 9 here, and for current here, we also is the text. So add 4 plus the current J is equal to 5 minus the 3 is equal to 9 plus 30 plus the 2 is equal to the 50, smaller than 6. Okay, so for here we gonna do the 9 plus 4 is 50. And for here 6 now, J moved to the 6 here. And we keep checking, right? This one is, if we add the justification, we're out of boundary. So we will not keep looping for that. So we can have this is 6 minus 0 is equal to 3 is equal to the current count. We have the 3 words, example and test. And the space is, the length is 50. So the space should be with space is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 30. It should be 30. Yeah, 30 should be this one. And for this one is like how many space we need. So we have the space and string builder, and it's where, okay, so I want to go to this way, so n should not be the -1, it should be n. And also I should not be the -1. I should be at 3 here. Okay, I don't want. And then it's we're going to this way and keep continue. And the I it will start at this here. Okay, now we keep doing the same thing. I is smaller than the n, so current now j is equal to 6. At the same times, where the last one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 30, 40, right? 40. 0 plus 40 plus the current j is 6 minus 6, so it's gone 40, smaller than 6. And then it's about going inside. For here, it's becoming 40, and the j is equal to 7 now. And the word count is 7 minus the 6 is equal to 1. Okay, so word count. Word. Just have only one words now. And the space is 30 minus the 40 is equal to 2. Okay, for here and just have a last line and have one word. So as we append the, if not, just have one word, right? Okay, smaller than j, k plus plus, append words k. And if k is smaller than j minus 1, append empty. Okay, we come into the last here. So last here. Int remaining should equal to the max. Wire the remaining larger than 0. Append. Okay, this one empty, and then for the remaining minus. Yeah, we can check. Oops. Why is happen? Let me refresh. I think my network or some problem. Oops. I don't know what's happened. Let's see. Okay, see what's gonna happen here. Okay, this one is right. Okay, for here that means The last one is okay. Okay, that one is okay. What happens here? I duplicate adding the k should smaller than j minus 1 at the same time, right? So this just makes sure I just added the space between the words, not the last one. Yep, and for the time complexity here, we just like for here is O1 time, like just O1, and add the, so the time complex I didn't create extra space, so it's a for loop for this one, right? And for here is the checking the current line here is O1, and for here is it's O1 time. So it's kind of like just the for loop for this one, and then we just make sure moving moving the 2 pointer to get the current line where start, and then we create a string builder to add the result in this one. So it's kind of like just mapping this one and put in the result. And for the result is O1 time, because we create a list string. Yep. So I'm feeling this one we check, right? So suppose this one is called like a k time. It's k time. This is the n, and this is for the k. So this is a k, and this is a k. So it's the time complex should be this one. Yeah, thank you.